Hello everyone, I'm glad to present our work on this international conference. I'm Ibra Lambusa under a guidance of Assistant Professor Shruti Patil from Symbiosis International University, Department of Computer Science and Engineering, Pune. I'm going to present our work titled Prediction of Driving Outcomes based on driver behavior and roadway information. Our presentation outline consists of introduction, statement of problem, related work, data preparation, driving outcome prediction, proposed system architecture, conclusion and reference. Introduction. With the growing of technologies in smart transportation, it is necessary to ensure road safety by improving the performance of advanced driver assistance system, which is called ADAS. ADAS are systems developed to automate or enhance vehicle systems for safety and better driving situation. It provides many applications by using different advanced technologies or devices to overcome or to create a better environmental driving situation. One of its application is creating or understanding the real-time risk. To overcome this or to have a better real-time risks, first we have to analyze how the driver interacts with and adapts the vehicle with the vehicle, traffic environment, roadway characteristics, traffic control device, and other environmental features which are crucial elements to predict real-time state of driving situation. This paper helps us in improving the prediction of driving outcomes by using specific variables of driver behavior and roadway information data. Statement of problem. To analyze and predict the driving outcome of a person based on driver behavior and roadway information. That means this work is customizable for each individual person that has its own driving behavior as well as it may observe the roadway information. Related work. We have been summarizing several papers and we summarized the references. References 17, 1, 2, 4, and 6 suggests or the evidences used for the data set we are going to use. Secondary Strategic Highway Research Program and Naturalistic Driving Studies is the dataset we are going to use. The SHRP2 is a research program studying the largest and most comprehensive NDS and RID or roadway information database ever conducted. It has many advanced technological devices to control different information regarding vehicle, driver behavior, and environmental conditions that are using to understand the real-time risk. And the second is references 1, 17 up to 20 are evidence or information or papers used for the model or classifier we are going to use. ElasticNet is a model we are going to use in our work due to the reasons, the ability that has variable selection, better test prediction, the ability to handle numerical and categorical inputs, and the ability to handle imbalanced data, and it works with highly correlated variables. The last one is the references 1 up to 2, 4, 6, and 11 up to 16 are information is used for the driver behavior. That the driver behavior is a major contributor to traffic safety risk. The next our outline is data preparation. In data preparation, the data set we are going to use is coming from Secondary Strategic Highway Research Program and Naturalistic Driving Study. And we are going to use data mingling and wrangling for data cleaning, punctuation correction, missing data handling, and data arrangements. The data taken from this Secondary Strategic Highway Research Programs consists of baseline video registered data and event video registered data, which includes detailed event, driver state, driving environmental information derived from video reduction. The baseline video reduction dataset is a dataset consists about the normal event, which consists of 19,600 baseline event with 27 variables. The second one is event video reduced data. It consists of crash and near crash events. 68 is for crashes and 760 is for near crash with 57 variables. Random sampling technique is applied on measure class or baseline event data to reduce the data size required to achieve a better classification accuracy. After the data reduction and cleaning, we have obtained 3,353 data set consists of 2,595 baseline and 969 near crash and 62 crash event datasets with 21 variables. The risk events are shown or represented by color spectra. For normal or baseline state, we have represent green, for near crash yellow, and for crash event red. This graph shows about the events in the horizontal and vertical number of data sets with their color spectrum. The baseline event decomposition. For creating a better safe environment for pedestrians as well as drivers, based on the unsafe driver behavior and secondary tasks that the driver involved, the events are further decomposed into 5 classes or outcomes. Accordingly, this table shows the outcomes as well as their meaning. The first one is baseline 1 or normal driving 1, which is the minimum risk. The second one is baseline 2 or normal driving 2, that is self-hazardous. The third one is baseline 3, normal driving 3, that is hazardous to self and others. The fourth one is near crash. The fifth, the last one is crash. This is more helpful for the drivers with limited skill. Okay, this graph or architecture shows how the events is further decomposed. Actually, only the baseline is further classified into 3. The near crash and crashes as it is. Okay, the baseline are further decomposed based on the driver behavior as well as secondary tasks. So the baseline 1 consists of no additional driving behavior as well as no secondary task. The baseline 2 consists of secondary task but no additional driving behavior. The last one, driving baseline 3, consists of some additional driving behavior. The near crash and crashes as it is. After baseline event decomposition, 2 colors are added as it is shown in the graph and represented by levels. Baseline 1 is green as it is, baseline 2 is green yellow, and baseline 3 is the khaki colors. Near crash is yellow and crash is the red one. And as we have seen in this graph, there is some imbalancing data in the data set we are going to use or in the events. Driving outcome prediction. Since you are working with the data that has majority and minority classes, the most techniques used to handle these are undersampling, oversampling, and bootstrapping techniques. The undersampling and oversampling are resampling techniques which are used to handle the imbalanced or majority and minority classes, but it doesn't consider how the data are scattered in the space. However, the bootstrap is a statistical resampling strategy. That means it is resampling with replacement that appraises the accuracy of the sample by utilizing a subset of accessible data or drawing randomly from the substitution from a set of data points or original data. In this work, we are going to use bootstrapping method to increase the accuracy of classifier and overcome such problem, and elastic net classifier to predict out the driving outcome, which is the supervised classification model used in many areas for variable selection, regularization, and classification purposes. This architecture shows the proposed system. Firstly, it is a data set we are going to take from the SHRP2 NDS, and then this data is going to be pre-processed. And this data cleaning, missing data handling is done. After this data is split into training and test data, then the training data is fed into the model, which is the elastic net. After the model is training, it uses the test data to predict the driving outcome results, which are shown by different colors. As conclusion, or to finalize, intelligent transportation or ITS helps the drivers in driving procedure to empower safe condition. In such a system, to guarantee the well-being of all street clients, it's important to upgrade the execution of ADAS for lower class of vehicles, especially for real-time driving safety risk. Okay, in this paper, we are going to use the second SHRPTNDS dataset and elastic net or elastic regularized multinomial logistic regression model for prediction or for classification are going to be used. As future works or further works, more variables can be used or which are customizable for each individual drivers that helps more for the real-time risk prediction and advanced machine learning algorithms to improve its performance. These are the references that we are using in our work. Thank you for your listening. If you have any question, you can contact me by this email ID.